Yes, hi everybody. I'm gonna do a quick update today. I got some parts out of a microwave. Big MOT. Very big MOT. Much bigger than that small one. Yes, and one thing I thought about was to punch this shunts out. See if it works better. Or maybe just burn the secondary on the primary. Or the primary on it. I think I burn the primary. Large magnetron. Thermostat on the side. Some brass wool on the top. Very big antenna output. Capacitor. I think it's Chinese. Samwa. Sounds Chinese. Oh, stands in German on the top. Can't actually read. The camera can't read that. Yes. Kondensatorn för mikrovällen kongerite. I think that's capacitor for microwaves. Microwave capacitor or MOC. Microwave oven capacitor. Yes, shaded pole. Fan motor from the microwave, and a high voltage fuse. 5 kV, 650 milliamps. That's a new ZVS I'm building on. New ZVS. Always good to have the new ZVS. Yes, big ferrite. Wound with Litz wire, of course. I don't want to use any other types of wire for the transformer winding. Same thing with the tunable coil. I'm going to solder that one in and glue it into place. Metal can transistor for if I want to auto modulate the output. Have that amplifier connected to that center tap or variable tap on the potentiometer. Very good output from that to drive gates for transistors. Yes, IGBT PSM 25GD 100D full bridge 3-phase. My CCDVS is supposed to run over 50 volts, so that's why I have 1.5 kilo ohm resistors, 25 watt resonance capacitors. Yes, it's actually the same heatsink on the amplifier and on the ZVS. But that one have a second plate for the TO3 transistors, but in this one I just removed that plate. Of course the screws are left. And the plate is here. Lots of transferring paste, heat transferring paste or something. Yes, of course, if you have never seen inside a magnetron, it looks like this. And take the other part as well. And there's the phone's reading glasses. Here they are. Yes, big lens. Yes, that's inside it. 10 poles. All of this is copper, very heavy. It had actually a better color when I grounded it, but when it had been in the air, oxygen had destroyed the copper to make copper oxide, and that's why it's a bit dark. And we have found the antenna now. Yes, there you have it. There's the antenna. It carries out the microwaves to that end. Of course, these ceramic insulators are dangerous. They're made of beryllium oxide. Very dangerous stuff. Never grind it and inhale the dust. Nasty stuff. It's solid copper as well. In the middle you have a double-poled tungsten electrode. There's one pole in the bottom there and another pole in the top. And between those poles you have a filament. Yes, that filament will heat up and it will give out electrons to the anode and make a lot of microwaves. Yes. Also this tungsten in the middle. Pretty heavy stuff. I took another one apart. Yes, I got lots of LEDs from school again. These are new. I got these things today. I have lots of other ones. I get lots of yellow and lots of red. And of course, you know, I don't alone in school. I have lots of other students as well, and those students have blown up lots of LEDs. These are just some of them blown up LEDs. They just connect them directly to a 9-volt battery, and they think that they may go pop. But of course they doesn't go pop on a 9-volt battery. Connect them in a wall socket when they will go pop. A wall socket can pop this thing, not a 9-volt battery. Just 9-volt battery just makes that little black dot in the middle and it no longer works. So I'm gonna give these LEDs a little capacitor makeup with lots of microwave oven capacitors and one ZVS. Or maybe I'll just charge it with a MOT. Oh, I have a better idea. I'm gonna rectify that one and charge this bastard up. Look at that. 40 microfarad, 5 kV DC. That will make the LEDs to light up. Yes, I have lots of other microwave capacitors. I have some other ones as well. That one is dead. These are alive. That one is alive. Yes, the problem with that microwave was that, yes, here in Finland we have 3-phase system, and of course the neutral get off. And what happens when you get the neutral off? Of course you think that you have a freezer that takes 200 watts, and you have a little microwave with a little control panel with a little transformer there and some other stuff. A little transformer, not that one, much smaller for a control circuit. Then you have a push buttons on the front, not that nice timer. And of course, when you have the neutral off, that fault current will go through the freezer and through the microwave's little transformer and kill the ICs, kill everything, and go into the other phase. That means that microwave get 400 volts through it, and that's what had killed it. Of course it killed the little MOV, and of course the MOV was too small. Of course, as you can read on the transformer, it stands Dongyang. Of course it means Chinese. Of course it's Chinese. They don't use so much powerful stuff. Has a little MOV on the circuit board. And of course, what blows? The fuse or the MOV? Of course the MOV blows up, burns, and when it's open circuit, the MOV of course, and that will have all the voltage let go through the little transformer for the control circuit, burn the control circuit, pop the capacitor on the control circuit and blow the transformer. Yes, that was the problem. The microwave. Yes, and the same thing happened with the TV as well. This little transformer inside there was dead as well. Little linear transformer. Not these types of ferrites. Linear ones like this one. But a laminated iron core. But much smaller than that. That one is actually pretty big. And of course, another problem. It's American. And third problem, it's popped. It has popped. Yes, we have 240 volts here, not 110. Yes, thanks for watching. Lots of nice stuff.